In this video, I'm going to walk through the third lab in the Flackbox free CCNA lab guide. It's a free download you can get from flackbox.com, which is from Neil Anderson. And he has a CCNA course you can take, but you don't have to. This is totally free to download. You can walk through all these labs. So let's get started. The name of this lab is The Life of a Packet. And this lab explores DNS configuration on Cisco routers and the ARP cache. So let's get started. Here's our topology, and configure the routers as DNS clients. And it says, note that routers cannot be DNS servers in Packet Tracer. I checked different versions of Packet Tracer, and unfortunately that's correct even now with the version 8, I believe. So we'll have to walk through and do it just like he says here. So it says the host with IP address 10.10.10.10, which is here, has been configured as a DNS server and is able to resolve DNS requests for router 1, 2, and 3. A domain name is not in use. So in Packet Tracer, if you want to set up a DNS server, you just grab a server from the devices down here and go into services, and then for example into DNS. And you can see he already configured it for this lab. His DNS service is on, and he's already added the 3A records for 1, 2, and 3 and the IP addresses. So it's super simple in Packet Tracer. You just choose the device, you can go into the server, you can go into services and set it all up. So the first thing we need to do is configure routers 1, 2, and 3 to use 10.10.10.10 as their DNS server. You do not need to configure a domain name or domain list. And so let's start there then. So let's open up router 1. Let's get to the command line. And let's go to privilege mode by entering enable. And let's get into global configuration mode. And the first thing we want to do is enter the command IP domain lookup. And you should be able to just tab to finish that out. Hit enter. And then the next command is going to be IP name server, and then you add the IP address of the server, which in this case is 10.10.10.10. So 10.10.10.10. Okay, that's done. I'm going to do something. No, that won't work. Okay, I'll keep going the other way. So let's go to R2, router 2. Let's do the same thing, command line. We're going to go into privilege exec mode, and then let's go to global configuration mode. And the first command again is IP domain lookup, and I just tab to complete, and then IP name server, and then the name of the IP address of the server, which is 10.10.10.10. Hit enter. That's done for router 2. Let's go to router 3, and we'll repeat the steps here. Enable conf t, and we're going to do the IP domain lookup command, followed by the IP name server command and assign the IP address of 10.10.10.10. Okay, that should be done. So that's step 1. Configure routers 1 through 3 to use 10.10.10 as their DNS server. Now it says to verify that you can ping router 2 and 3 from router 1 using their host names R1 and R3. So let's go to router 1 and let's try to ping. First we need to hit go back down to privilege exec mode, and we're going to ping, and you can just simply use the host name, which is already configured in the server over here like I showed you earlier. So you can do R1, or it's not case sensitive in the command line unless you're doing things like piping commands. So in this case, we're just going to use lowercase and hit R1. It'll take a second because it takes time to go through the process to resolve it. But to speed things up, you can just hit this little button right here in Packet Tracer, and that jumps you forward about 30 seconds, and there we go. So we issued the command ping I made a mistake. We should have been ping. I was pinging itself. So let's ping R2 from R1. We'll do that, and we're going to jump forward. Oh no, there it goes. It did it. So we've got the command ping R2, and we have success. So it was able to do it. The first was probably an ARP, the fail, the dot or the period indicates failed response, whereas the exclamation point is successful. So that worked. And then now we want to ping R3, so we'll just use the up arrow to bring up that command, put in 3, we'll give it a moment to run through its process, and yes, it did it, so success. So we've got that. So we finished the step, verify that you can ping R2 and 3 from R1, which we did. Now verify that you can ping R1 and 2 from 3. So let's do that. So we're going to go to router 3. We're going to type in N, get back to privilege mode. We're going to type conf T to get to global configuration mode. Conf T is just short for configure terminal. And now we want to, we're at router 3 and we want to ping router 1. Move this out of the way. Oh, I'm in the wrong. Let me drop down a level. I need to be in privilege exec mode. So it's ping R1, and we'll give that a moment to run through its process, and it should hopefully show us that it's not having any issues. I'm going to jump forward in time 30 seconds here, and there we go, success. So we pinged R1, and it was a success. So now let's bring up hit our up arrow to bring back our command, replace the 1 with a 2 for router 2. Let's ping router 2, and it's also a success. So we were able to verify that you can ping router 1 and 2 from 3. So the next steps are, we're going to examine the ARP cache on the routers. Do you expect to see any entries for router 3, which is here, in the ARP cache of router 1, which is here? Why or why not? Well, router 1 is part of the 10.10.10.0 network. It's part of 10.10.10.10.0/24. But router 3 is part of the 10.10.20.0 network. And ARP, which is an address resolution protocol, it maps IPs to MAC addresses, uses broadcast traffic. So broadcast traffic won't get past router 2 because the router is not going to send out broadcast traffic. So router 1 will have entries in its ARP cache regarding devices that are on its directly connected network, all part of the 10.10.10.0, but it's not. I don't think it's going to have anything for the 10.10.20.0 network. So why or why not explain that? And it says verify the ARP cache on routers 1 through 3. What do you see? So let's go to router 1 and get down here. Make sure you're in privilege mode, and we're going to issue the show ARP command. And let's take a look at what it has in its routing table. So I'm going to open this up a little bit, and it's ARP cache, sorry. So it's showing 10.10.10.1, which is its interface here, and then MAC address. It's showing 10.10.10.10.2, which is this interface on router 2, and it shows this MAC address. So let's just look at the last 4 characters in the MAC address, and let's pull up router 2. And let's hit end, and let's do show interfaces, and we're going to do fast Ethernet 0.0, which looks like that's on. And if we pull this up a little, we're going to look for the MAC address for router 2's fast Ethernet 0.0. The MAC address ends in A9A5, and that matches up to what we see here. So that's right, that makes sense. It also sees 10.10.10.10, which is the server over here. So again, router 1 in the ARP cache has the locally connected devices on its local network, but since ARP requests are broadcast, it's not going to go past this router and won't know about the ones in the 10.10.20 network. So now let's go to router 2. Well, actually, let's do it this way. Let's go to router 3, and let's do issue the show ARP command, and it'll bring it up for us. And for router 2, we see its own interface of 10.10.20.1, and we see 10.10.20.2, which is the interface for router 2 up here. So let's go back to router 2 and let's look for the ACA0 last characters in the MAC address, and let's go. I'll hit that, and we're going to just use the up arrow to issue the command, and it's going to be fast Ethernet 10. And let's look at that. So we're looking for the MAC address, which will be right here, and it ends in ACA0. So you'll also see it as BIA, or burned in address, and it's just repeated there. So ACA0 is what we find on that one, and when we come down back to the results of the show ARP command on router 3, it shows 10.10.20.2, which is here, and the MAC address for that ends in ACA0. So that's correct. Now let's, and again, router 3 is not going to have any entries for this network because it's only going to have for the devices on its directly connected network, because these are on the network, the same network. And now let's look at R2 this time, and we'll hit the space bar, and we're going to do a show ARP command. And this will be a little bit different from the others, because as we pull this over, the first thing that we see is 10.10.10.1, which is this interface on router 1. Okay, so that's part of the 10.10.10.0 network. So R2 is definitely directly connected to this network. You see 10.10.10.2, which is going to be its own interface here, also on this network. And you see 10.10.10.10, which is the server over here, also part of the 10.10.10.0 network. But unlike the other two routers, our router 2 is connected to two different networks. So when you issue the show ARP command, you're going to see information about both of these directly connected networks. So as we look over here, we see 10.10.20.1, which is the interface for router 3 down here, part of this network. And we see 10.10.20.2, which is its own interface on router 2 here. So again, ARP is broadcast. It won't go past the router. It'll only, when you do the show ARP command, reflect the devices in a directly connected network. So for each of these, it's a single network, but for R2, it showed devices in two networks because it's directly connected to two networks. And view the ARP cache on R1, 2, and 3. What do you see? And then that's it. Pretty simple. It was fun. In the Flackbox, you'll see that they give you the instructions. You start off here, you work through them, and then if you need to get the answer key, it's below. So it's super helpful because it's right there for you. But always try to walk through it on your own without the answer key. So that ends this video. I hope you enjoyed it, and I will do the next lab as soon as possible. Thanks.